Let's say that I have a lot of glass slabs kept here. The object is here. This distance is d1, d2, d3, d4. It goes on, and I have the thickness of the glass slabs as t1, t2, t3, t4. It goes on. There are, let's say, n glass slabs kept, and the distance varies as d1 till tn, and the thickness varies from t1 to tn. The question is, what is the final shift in the object position? The answer to this is, the shift is, as you know, irrespective of the position of the glass slabs. So the shift will be addition of the shifts produced by individual glass slabs. So it's actually, the shift will be equal to ti 1 minus 1 by, let's say each has a refractive index of mu I, mu1, mu2, mu3. So this is the final shift of the object position. Okay, now let's take an example. You know that, let's recall what we have learned. You know that when a glass slab is introduced, shift in the object position occurs. The shift is in the direction of the traveling of the rays. And the another thing which we learned is, when ray of light moves from denser to rarer medium, the object appears to, and the object is in the denser medium, the object appears to move towards the surface. When the ray of light moves from rarer to denser medium and the object is in the rarer medium, the object appears to move away from the surface. Okay, that's it. Now we'll take few examples and then we'll move on to refraction using spherical surfaces. The question is, a slab of thickness 3 centimeter and refractive index 1.5 is introduced normal to concave mirror close to the pole of the concave mirror of radius of curvature 40 centimeter. It's said that the image location coincides with the object location. So the image location, if the object is placed here, the final image also forms here. So the question is, what is the distance between the object and the image? Let's say the image is formed here. So what is OI? For a magnification produced by the whole setup, the magnification is 1. So I hope you got the question. You have a concave mirror with a radius of curvature of 40 centimeter. You have a glass slab of thickness 3 centimeter and refractive index 1.5. The glass slab has been introduced close to the pole of the concave mirror. Then you are asked to find that what is the distance between the object and the final image for a magnification of 1 produced by the whole setup. Okay, so you try this question on your own and let's proceed with the solution after you have done with your own solution. Okay, magnification. When is the magnification produced? Can the glass slab produce the magnification? No. So the magnification is produced by the concave mirror. So what is the magnification produced by concave mirror? It's V by U, which is equal to 1. That means the image distance is equal to the object distance as seen by the concave mirror. And when does that happen? When is the object distance same as the image distance? When the object is placed at the radius of curvature. Okay, so for this concave mirror, the object should appear to be coming from the radius of curvature. So to this mirror, the object should appear to be at the radius of curvature at this point. But where does the object is exactly? Where is the object? The object, you know, if this is the object, because of this glass slab, this mirror will see a shifted image of the object. So if this is the position of the object, so the shift is equal to thickness times 1 minus 1 by mu, which is equal to 1. So this glass slab introduces a shift in which direction? In the direction of the rays. This direction, the rays is traveling in this direction, so the shift is in this direction. So what happens? First, this slab will introduce a shift of 1 centimeter in this direction, and this mirror will see the shifted object. So the shifted object should appear at the radius of curvature. That means the original object is at 1 centimeter in this direction, 240 centimeter. So actually the object distance is 40 plus 1 centimeter is equal to 41 centimeter. I hope you understood this. Let me briefly explain this again. See, if the object is kept here, you have a glass slab. The glass slab will shift the object position by 1 centimeter because of this. Now this mirror will see the shifted image, and that shifted image should appear at the radius of curvature. Okay, so the shifted object will come at this point. So my object is at 41 centimeter. Clear? Now this mirror will form the image at this point itself, but now the rays of light are coming in this direction, right? So this image formed by the concave mirror will again get shifted by the lens in this direction by 1 centimeter. So my final image will be formed at 41 centimeter itself. And now the shift is in this direction because the ray of light from the mirror is in this direction. It hits the slab in this direction. So the shift is also in this direction. So my image position is 41 centimeters. So the difference in distance between object and image is 0 centimeter. Now let's take another example and we'll move on to spherical surfaces. The question is like this. You have a glass slab. One side of the glass slab is silvered, and you have an object here at a distance of d0, and the thickness of the slab is ds, and it has a refractive index mu. So the question is, find the distance between the object and the image formed by the whole setup. Remember, in this question you can't apply the formula like shift is equal to d1 minus 1 by mu, because that shift was valid because when we had a glass slab placed in a medium, and this medium in both sides was same, and there were two refracting surfaces. This was first surface, this was the second surface. In this case you have only one refracting surface here. Here you have only a reflection occurring, and finally the rays while returning we have another refraction. So we have two refractions here also, but the refractions are at the same surface and we have a reflecting surface here. So we can't apply this formula. This formula we can't apply. So we'll go by surface. For this surface, you know, when the object is in the rarer medium and I am here in the denser medium, the image formed by this medium will shift away from the surface. So my intermediate image is formed here. What is the distance? It will be mu times d0. Now the second reflection occurs. The distance is what? Mu d0 plus ds. So the image formed by the mirror will be at a distance of mu d0 plus ds. Now this object appears as the image, this image appears as the object for this surface. So for this surface, the object distance is mu d0 plus ds or mu d0 plus 2ds. So where is the image formed? This object will form an image, and the image will now be shifted towards the surface because it's denser to rarer medium, and the shift or the position of the image will be this divided by mu. This distance is this. This distance is given by this. So what is the distance between the object and the image? It's mu d0 plus 2ds divided by mu plus this distance. This is the image distance plus this distance. So it's 2 times d naught plus ds by mu. Okay, so this is my solution. Now let's move on to spherical surfaces.